Hi, this is going to be a short video on closures in Swift. Okay, I have a tutorial section here on GitHub, and I'll post a link to this in the video comment, so you can go here and read through the tutorial and link to the files that are mentioned. And anyway, let's get started. So, what I'm hoping we're going to do here is understand what a closure is, be able to identify closures commonly used throughout UIKit, and then write some closures yourself, and then create a system, or do a little practice with closures to create a system that does something practical with them. Okay. So introduction here. What is a closure? Well, a closure is a self-contained block of functionality. Okay. Sometimes closures are called blocks, lambdas, anonymous functions. These are names used in other languages. If you're familiar with closures or anonymous functions in JavaScript, you'll be familiar with closures in Swift. Okay. If you're familiar with functions at all, if you've used functions before in any programming language, you'll be familiar with closures. Essentially, in Swift, a function is actually a special case of closure. So essentially, every function you've ever written is a closure. So anyway, so there we go, right? What can you do with closures? Well, you can pass values. You can pass them as values, right? So a closure is a value. Like imagine like a block of code that you can pass along or give to somebody else, or pass it into a function as a parameter, set it as a value for a variable, just like setting an int or a string as a value for a variable. Okay, closures can also capture or enclose values, right? That's where the name comes from, closure, because they enclose a value. And I'm going to talk more about that at the end, because that's a little more abstract and a little more, that's probably the most complicated part of the whole thing, right? So how to use closures in Swift? Well, I'm going to go get this playground right here, the closures playground, and then I'll open that up. And we'll take a quick look. So what does a closure look like? Well, let's start with a function. So a function looks like this in Swift. You say func, and then you say the name of your function, and you follow it with the parentheses and the curly braces. And inside the curly braces, you will have, some code. So your code goes here, and you might have a whole bunch of code. This function just prints out the name hello. And if you were going to call on your function, you'd say hello, like this. And then you can see it says hello over here, right? So how would we do something like that with a closure? Well, a closure looks like this. It's essentially the code block for the function, and you're assigning that code block to something. And in this case, I'm assigning it to a variable, okay? So you can see that this is very similar, right? And you would call this closure in the same way that you called the function. I could say message, and then I could type the parentheses on the end, and you can see, actually it doesn't say what's up here, but it does run the code there, or at least it hasn't updated here yet. But anyway, that's our function, right? So closures can also take parameters. This function right here, you can see it doesn't take any parameters, and I didn't use any parameters on this function, or sometimes they call parameters arguments, right? I'm going to use the name params here, right? So if you want to create a closure that takes parameters, you can write it in this form. You can say, curly brace, right? There's your closing curly brace. And then you follow it with your parameters. And then if your closure also has a return type, you can set the return type here, followed by the little arrow. And then you say in, and then you have your code block. So for example, here's our function up here without the parameters and without the return type. I don't know if it'll let me do this, but if I, type in that, this is kind of like saying my function takes no parameters and returns nothing, right? So this is kind of like an item that you can include, but if you don't have any parameters, you can leave that out, right? So that's what I've done here. So down here, if you wanted to include a parameter, here we have the parameter a, which is a string, and then this function or this closure is going to return a string, and then it can do something with the a and then return the string here, okay? Here's a practical example, right? I've got the multiplier. I've got a closure here that takes two parameters, a and b, both integers, and then it returns an integer. And then I say, parameters, return type in, and then I can do anything I want inside my closure, my code block, right? And it runs, and this essentially multiplies a times b and returns that as a value, okay? Returns an integer there. So you can see here I'm testing out the multiplier. I can multiply 3 times 4 and I get 12. Or I could say, you know, how about 6 times 8 and I get 48, right? Okay, so you know, here's an exercise for you. Why don't you create a closure, write a closure for yourself that adds 2 integers together. You can use this as a model, right? And then you can make a subtractor. You can just stop the video and do these two, these two examples here. So make a closure that subtracts one integer from another and returns the value, right? Okay, and then if you want, if those are too easy, make up your own math function here that takes 2 integers and returns an integer, okay? So to continue, you know, closures can also be passed around as values. So, you know, you can see up here we're assigning the closure to a variable here, right? And down here I can take that variable and assign it to another variable, right? So I can say last operation, right? And then last operation is a function that takes 2 integers and returns an integer. Okay, so here I can say 2, 7 and I get 14, because that's what the multiplier would do, and last operation essentially is the multiplier, right? So you could try that. Here's another exercise. Try this, you know, assign your closure that you created above in the last exercise to last operation and then run it here, okay? So another one here is like kind of a longer, you know, a more like kind of abstract idea of what things you can do with closures. Here you can call this like a higher order function. So essentially a closure can be passed into a function as a parameter. So this is something we haven't done yet, right? Here you can see I have a function called doMath, right? And you can pass in a and b, so it gets 2 integers. And then you can also pass in an operation. And so the operation can be any function or closure that receives 2 integers as parameters and returns an integer. Okay, so any of the operations that we created up here, like the multiplier or the adder and the subtractor, right? Or last operation could be passed in as the parameter here, right? And then this will just print out the value. So you can see here, doMath, if you pass in 33 and 21, and then set the operation to multiplier, then it should multiply these 2 numbers and print the value here. This says 2 times because I called it again down at the bottom here, right? You know, if I comment this out here like that, then maybe it'll show me the answer for the first one there. I guess it's not going to do it. Anyway, there you go. There's a quick introduction to closures. Let's do a little more practical stuff with the closures, right? So that's the first example, kind of a short introduction. So what else can you do with them? I've got a project file here called closure1 example, and this one is a practical example that I'll run it right now. It uses some of the built-in UI kit features to make a simple app that uses closures, right? So here we have a button, and if you tap the button, it opens up an alert dialog box, and you can type in your name and your password, and then you can click OK, and then, you know, it doesn't do anything. It just colors the background black when you open the dialog box, and then changes the background color back to white when the dialog box closes, right? Okay, so what's happening here? Well, this app is using closures to do a lot of its work, and these are just built-in classes that are in UIKit, right? So they're built into UIKit, and the UIKit classes use closures, right, to do their work, right? So you know, as an exercise here, you can look at this app. You know, you can stop the video now, look at the app, and try and find all of the closures in here, okay? And then there's another exercise here. You can create your own UI alert action that sets the background color to red, right? I'll talk about this, and then the second one maybe will make more sense, right? Okay, so, when I did this, I counted 14 closures. I don't know how many you counted. Maybe it's a trick question because I actually counted all of the functions also as a closure because, like I said earlier in the video, a function is just a special case of a closure. So essentially, the function is a closure with an identifier. Okay, so it has a name, right? That's what's special about it, okay? And you can see these code blocks here in UI view with animation with duration, right? This doesn't have a name associated with it, right? So this is why sometimes closures are called anonymous functions, right? Because they don't have a name, okay? So anyway, so what do we have here? Well, let's go through and do the second one here, the second exercise. So the alert dialog box here is created with the UI alert controller, and when we initialize the alert controller with this, it actually has two initializers, but this initializer is title, message, preferred style, okay? So this creates a UI alert controller, which is really just another view controller, and we can present that view controller with present view controller down here, okay? So there's no closure here. When we add buttons to the UI alert controller, the example has a cancel button and an OK button, right? We're going to create those with UI alert action. And UI alert action takes a couple parameters, right? So let's make another one. We'll call it red, right? So we'll say UI alert action, right? And when I get this initializer here, this is title style handler. Handler is a closure, right? So it takes a UI alert action as a parameter and it returns void, and it's optional. Okay, so this isn't how you might write an optional closure, right? Or describe the type for the closure. I'm going to talk more about types, and this would really be the type, right? So what we do with the red button, well, I'll say the title is going to be, red, and then I'll set the UI alert action style to how about default, right? And then the handler now is a closure, so we can write any closure in here, just like we did above. And if you are using the code hints here, when you get to this one, if you have it selected, right, like in this state, when you hit return, the IDE, the Xcode, will write the code for you. And it does kind of a funny thing here. You can see that this is the function. It begins here, and it ends at the parentheses. Inside here, what it's going to do is it's actually going to take that parentheses and move it over here to the end of default and write the trailing closure on the outside. And that's sort of like, they'd call it syntactic sugar. It's just like a little bonus way that you can write this. You could actually write the handler inside here with the parentheses on the end if you wanted, but Swift provides this little extra thing, like if the closure is the last parameter, then you can write it outside of the function. Okay, so if I hit return here, that's the way that that Xcode is going to write this. Okay, so anyway, this is a parameter that our closure takes, and you can just name this parameter anything you want, though it has to be type UI alert action. So inside here, whatever name we put there is going to be a type UI alert action, right? And then we can say in, and then this is the block of code that we're going to execute. So if we wanted to set the background color, we'd say self.view actually let's animate the background color, right? So we'll do UI view dot animate with duration. Let's do a duration of 1 second, and then oh look, animations is a closure, right? A closure that takes no arguments and returns nothing, right? So we'll do the same thing we did before. I'll select this one and hit return, and you can see that actually this time it didn't write it as a trailing closure. It left the parentheses there. Go figure, right? Anyway, what will we do here? We'll say self.view.background color equals UI color.red color, right? And this should animate the color of the background over the course of 1 second to red, right? When you create a UI alert action, essentially what you're doing is you're making a button, and when you tap that button, the code that you want to execute is going to be this closure block that you wrote, okay? So that's kind of, points to the way that we use closures, because closures are there for situations where you want to add some functionality to something, but you can't execute that functionality at the moment. You need to do it later on when it's more convenient, or when something happens, be it an event or some other action happens in the program, right? So essentially, we need to create the button now when we make the dialog box, but it's not necessary that someone's actually going to tap the button yet, or they may tap it sometime in the future. So we need to attach some functionality to the button, and we're doing that through a closure. Right? So anyway, so there's our closure there. I wrote this one a little different. The ones down here, you can see this action, when it says do login, it's actually going to call a function down here, and do login, calls the fade up, which actually, fades the background color to black, right? So I just kind of wrote it inside here. It does the same thing though. Anyway, let's test it. Oh, I got to do one more thing. I forgot. So when we create a UI alert action, if we want that action to be attached to the UI alert controller, we need to add it to the UI alert controller. And I did that here when I created the OK and the cancel button. I said alert.add action, right? So if I want to add the red button, I'd have to say add action red, right? So I got UI my alert controller.add action, and then red is the name of the button that we made it, or the UI alert action right here. So we're adding the action to the alert. Anyway, there we go. Let's test it now. So I'll click test. Now I get the red button, and if I tap red, the background color changes to red. Okay. So anyway, hopefully you were able to do that on your own, and good for you. And if not, you can follow my example here and take a look at what you did, and maybe you'll even learn more, like figuring out what went wrong, right? One more thing. This present view controller down here has 2 parameters, right? Or 3 parameters: view controller, animated, and completion. Completion is a closure. And you'll notice here, I didn't write the closure with the curly brackets. Instead, what I did is I just put the name of a function here. Now remember, let's type present view controller, right? And if I did presented view controller, I went present view controller, right? And if I type in alert as my view controller, animated can be true. And then you'll notice completion is a closure. It's a function that takes no parameters and returns nothing, right? So any function can be used here. So remember, a function is just a special case for closure. So any function or closure that fits this signature, takes no parameters, returns void, will fit here. And so I actually just put in the fade back function, right? And if we look at fade back down here, you can see this is a function that takes no parameters and returns nothing. Okay, so any function that fits that description can work for the completion here. Okay, so anyway, so there's another thing about closures, right? So anyway, so there's a good example there. Hopefully that's helpful and informative. So what's our next step, right? So let's talk a little bit more about types here. Okay, so just remember, a closure is the type for the closure is the description of the function that it would create. So the parameters it takes and the parameter or the values it returns. Okay, the code block can be anything. Okay, so the code block doesn't matter. It's just what parameters the function takes and what parameters it returns determines the type. Okay, so any function or closure that fits that description will work for any type that you've declared, right? So anyway, let's continue here. I have another example here with MS Button Node. This actually is in a project using SpriteKit. So if I look at SpriteKit here, you can see I have a simple project that just creates a button on the screen, and when you click it, it just says normal and active, right? So this is the art for the button, and this is done with the Button Node class. So when I look at Button Node here, you can see that it has a a property here called selected handler. So selected handler is a function, right, that takes no parameters and returns nothing, and it's an optional. So here's a little note just about the syntax. If you create a type that is a closure, right, and it's optional, you have to wrap it in parentheses and then put the question mark on the outside. So here, just like you would set the type here to skTexture, you say the name of the variable and then colon skTexture. Here I say selected handler colon, and then I name the or describe the function that this handler will hold on to, right? Okay, and then I set a value here, right? We could have set this to nil also because it's you know, optional, right? So what you need to do here is go into game scene and assign this selected handler some function that does something. You can do anything. You could print something out on the screen, or you know, I don't know, do anything you want. But give it a try, right? So you could stop the video and do it on your own. And then I'll answer the question here. So essentially here I've got an instance of button node here that I've created called button, and then at the bottom here I can say button dot selected handler equals, and then now I just need to write the code, so I'll write the curly brace and I can say print, and I'll put some stars in there, and I'll say button, okay? And then I can test my project, and essentially this block of code is going to be run every time, you know, you click the button, right? So you can see there's the text there. So how does that work? Well, essentially button node class, when you assign your closure to the selected handler, if you recall how we ran the closures in the very first example, when we go to touches ended here, we check to see that selected handler is not nil, right? So we use the Iflet syntax, and then we just say selected handler and follow it with the parentheses, and that runs the function, okay? So anyway, so there's another example, right? And then obviously we'd use that there because now you could create the use case there for the closure is that the button, you know, we could create any kind of button, and all of our buttons might need to do different blocks of code when you run them, right? Or when you tap them. So that, you know, the closure makes it very easy for us to do that, right? So let's move on to our next example. So this next example is another SpriteKit example. And in this example, we have a joystick. So, you know, if we test the project here, you can see I've got this red square. This is going to be part of the exercise, right? But if you tap the screen, the joystick appears, and as you move your mouse around, the circle here follows the mouse, right? Okay? So if I click and I drag, then the circle follows the mouse, right? I'm realizing it doesn't hide. I need to hide it. So I got to do this. I got to say touches ended joystick dot hide, right? And that'll put the joystick away. Let's test it again. Oh, there we go, right? Okay, so right now what we have is a more complicated problem, right? I want you to modify this class to add a variable inside joystick, right? The joystick class here, that will allow the joystick to take a closure and then act on that closure, right? So the idea is you need to add a property here that will hold the closure, and the closure needs to take an X and a Y value. And the joystick has an X value and a Y value, and it wants to pass those two values to the closure, right? Because they determine the joystick position. Okay, so you can run any code you want inside your closure when you set it, but the joystick here needs to define a variable that will take the X and Y parameters, okay, and it should return void. And then in the move method here of the joystick, you're going to call that closure. Okay, you're going to call on it and then pass in the X and Y value. or the X value and the Y value, okay? And then you could use that if you want to move the box on the screen. So if you're not familiar with SpriteKit, you could think of something else to do if you're familiar with SpriteKit. I think I created the box here and I gave it a physics body, so you could use apply force with the joystick to move the box or push it around on the screen. Okay, so give that a try. Stop the video and then I'll do the example, right? Okay, so let's give it a try, right? What do we do? Well, first of all, we need to make a variable here that will be our closure. So we'll say, what do we call it? Let's call it Joystick Action, right? Okay, and it's going to be type, a function here that takes two parameters. Let's call them X, and it'll be a CG float probably, and a Y, which will be CG float, and then it returns nothing, okay? And then maybe we'll take the same strategy that we used with the button, because you might not set the value, so the joystick might not have its joystick action set. So why don't we wrap that in parentheses and put the question mark on the end, right? So now what are we going to do? So down here, we're going to call on our closure. Why don't we use the Iflet syntax? So we'll say Iflet joystick action equals joystick action. So if that's set, then this should unwrap joystick action here, and then we can say joystick action parentheses, and you'll see that it takes two parameters, X and Y, right? So what we'll do is we'll say X value can go here, and the Y value can go there, right? So now if you set the joystick action, then it will call on this closure and pass in the X and Y value. So how would we use it? Well, because this isn't going to do anything by itself, but the joystick now can do something as long as we set the action, right? So let's give that a try. Going back to game scene right here, what we'll do is we'll set our joystick action. So we'll say, what is it? Joystick action equals, and what we need to do is we need to set the type here, right? So it's going to take two values, right? It's going to take an X, which is a CG float, and a Y, which is CG float, and then we'll say in, and then we'll do our code block here, okay? So what are we going to do with the code block? Well, I've already got the box here, and I said it was a physics body, so we can just say box.physicsBody dot, how about apply force, and then we need to make a CG vector, so we'll make it, how about X and Y. We might need to multiply this number times some value, but we'll start with that, right? What is it not like here? Oh, you know what? I forgot the parentheses there. And then something is missing here. Oh yeah, I got to do self because we're inside a closure. I'm going to talk about that in a moment too. So anyway, let's give it a try, right? And there we go, right? So oh, there's my joystick. It's kind of working. Oh, it's moving really slowly. Let's try this. Maybe I got to multiply this times, the joystick, the X and Y values return a value between 0 and 1, right? Or actually -1 to +1. So it's -1 if you're on the left, +1 if you're on the right. So why don't we multiply times 100? Something like that, right? And we'll give it another test. Oh, there we go, right? Hey, so that wasn't too difficult, right? And you can see this actually makes the joystick pretty useful, right? You can just assign any action to it, and the joystick is going to give us the X and Y, right? So anyway, so there's another example for you. And then let's try one more example. So I have another example here under the section capturing values. So just a note, closures can capture variables that exist outside their local scope. So the variables, though, that they capture are in the current context, or you can think about it as being the current code block that the closure exists in when it's created. Okay, so I have one last example for this, and I'm going to go get that, and it's I think it's this one here, number 2, right? And in this example, you can see I've got a function here called MakeCounter. And what's interesting here is earlier we did a function that took a function as a parameter. This function returns a function as a return value. So it returns a function, right? It returns a function here that takes no parameters but returns an integer, right? So this returns a function that takes no parameters and returns an integer. So you can see inside here, MakeCounter sets a variable called count, and then it defines a function called counter that returns an integer, and then it returns counter. And counter, matches the description here, right? So counter is okay as a return item. Now, what's interesting here is that count, this variable that's declared inside the MakeCounter context, let's call it, or code block, right? Or maybe scope, I don't know if that's quite the right word, but anyway, this variable count right here is captured by counter. Okay, so counter kind of keeps a reference to this count variable, and you can see down here when I say MakeCounter, I make counter number 1, and when I call counter number 1, it prints the value or returns the value of count, right? It adds 1 and returns the value. So count had a value of 0 when this counter was returned, right? And then it added 1 when we called it here, so it prints a 1. And then when we call it a second time, it prints a 2, right? And you can see count is not declared inside counter. Instead, it's declared outside, but it gets, captured by the closure, right? This is the closure here, and it kind of captures this from its current context, okay? So anyway, so your problem now is to take this idea and create an iterator. Okay, so an iterator essentially will take a parameter here that will be an array, and it'll return a function that will return an item from that array. So every time you call the iterator, it's going to return one of the items from its array that it's going to capture. Now, here's a note on this, that counter doesn't take a parameter here, right? But if you have any parameters in a function, the parameters that you pass into the function are also captured in the same way count was. Okay, so if you pass a value here, like for example, if I was to add a variable here called, a, and it was an integer, right? The a would be captured here, and I could do this. I could say, let's return a, 1, let's do times a. Okay, so that's kind of weird, right? Like, how does the a get in here, right? Now, in order to make the counter, what if I did, what if I do a is 3, right? Okay, so now you can see that when I call counter the first time, it sees a. Actually, I guess I could just do that, right? Okay, so you can see now that the a is added to count, right? And so it says, hey, counter is 3, right? And then it does it as 6. So you could say this could be like a variable that also gets captured in the closure, just like count did. Okay, and so you could multiply a times 2, and we can see that it's going to change its value. Like the first time it's 6, and then it's 12, right? So anyway, so parameters are also captured with the closure. Okay, so your goal is to pass an array into the closure, and then your closure is going to return one of the elements from the array every time you call it. So it should return the first element, and then the second element, and then if you called it again, it would return the third element, right? And you can see here I kind of got you started. You're going to make a function that makes an iterator. You pass in an array, it returns a function that returns an item from the array. So I have array of strings, so iterator is going to return a string, right? I made this an optional so that, for style points, if your array gets to the end and runs out of items, you can return nil, right? And then you're going to write the code here for your closure. And then, you know, it should work like this. You should be able to say make iterator and then pass in an array like ABC. And when I call iterator here, it's going to return the first item from the array. And when I call iterator again, it's going to return the second item and then the third item, and then it should return nil. Okay, so you can stop there and try that on your own. And then after that, you know, I'll go through the solution, right? So anyway, so here's our solution here. So I did a make iterator. It takes an array of strings, and then it returns a function that returns a string or an optional string. Okay, I started the index at -1, so this array variable and the index variable are both captured by this function here that is our closure, right? And whenever we call the iterator function, it adds 1 to index, and then it just checks, and if index is greater than the count of the array, it returns a nil. Otherwise, it returns the item at that index in the array. Okay? And then, you know, this is our function that is the closure function, and we just return that. So, you know, when you make your iterator, you're going to say make iterator with this array, and then it's going to return the function here, right? This function is going to be inside iterator, and so when we call iterator here, you can see it's A the first time, B, C, D, and then nil, right? And then you could do more with this. I started one here that's make goblin, so you could use this to keep track of your monsters or something. But anyway, so there you go. I hope that's interesting, and thanks for watching.